For those of y'all at home, the class was given time to see if they could figure this out, so pause the video, see if you can figure this out before I do. Okay. I bet most of y'all were able to do this. You were able to figure it out. But what's funny is that if I were to come around and look at how you figured it out, your notes might be kind of messy, or some of you might not have notes because you were just plugging numbers into a calculator, or some of y'all are just absolute cheaters and you went to Google, all right? Shame on you. However, there's a best method. There is a right way to do this, and I need you to learn the right way. It's called dimensional analysis. Go ahead and have your spiral out still. That's dimensional analysis. The process that I need you to learn how to do to solve long conversions is dimensional analysis. And I'm about to go through the steps on how I would solve this very systematically. And if you're thinking to yourself, nope, I like the way I did it better, that's not going to work. And the reason that's not going to work is you might be able to rationalize this question. But if my question was instead, how many moles are there in 5.02 E36 atoms? You can't rationalize that, nor can Google help you. Because those are units that you just don't, you can't fathom. But my process here, of course, now that I press record, I'm going to lose my ability to talk. Sorry, y'all. The process of dimensional analysis can solve any conversion, and it's also what college professors prefer. So, bear with me, and you'll understand how I'm coming up with these steps. How old are y'all, by the way? Is it 15? Is that the age for the most part? 4 years old? No, how old do you act? How old are you? Oh, it was 14. Let's pretend that you're going to turn 15 in 5 minutes. In 5 minutes, you're going to turn 15. I know, right? That's what I'm good for. So let's say that you're going to turn 15 years old in about 5 minutes, which is hopefully about as long as this will take me to explain. Here, I want you to draw what I draw. Watch this. I'm going to draw a long line like that, and I'm going to draw off a first section like that. And what I start thinking about is, what can I break years into? Like, I know I can break years into weeks. What are weeks made up of? Weeks are made up of days. What are days made up of? Days are made up of hours. I bet you know my next question. Minutes. Now, I heard someone say seconds. We could, if the question was different, I would just go to seconds and it wouldn't change. The process is still very step by step. Now, so across the top of my dimensional analysis is going to be the sequence of unit changes that I'm doing. Now, here's a weird thing. In the bottom squares, what I'm going to do is I'm going to take whatever unit is in the top one and I'm going to drag it down to the diagonal. I'm not going to bring any numbers down. I'm just going to take whatever unit's right there and rewrite it down there. So here, it's years. Here, it's weeks. And then so on and so forth. All right, so the diagonals always have matching units in dimensional analysis. It's a norm that you'll just get used to. Here's the next trick. Every pair of squares has to equal each other. They have different words, but we want to input numbers that makes them the same. Like if one of them said 12 inches, what should the bottom one maybe say? 1 foot, because 12 inches and 1 foot are the same, even though they're different, right? So with that said, what two numbers makes these the same? 52 weeks in 1 year. 52 weeks in 1 year. What numbers make these the exact same? Nope. 7 days in 1 week. Right? All right, now you're right. If we had days and year, which we could have done, their 365 would be one of our factors. I didn't set it up like that. What about this one? Hours and days. What's the number? 24 hours in one dia. What about the last one? 60 minutes in an hour. By thinking through it like this, we can all figure out questions like this in the exact same way, because now the math is really easy. Here's what you do on dimensional analysis. You're going to multiply across the top and get a number. You're going to multiply across the bottom and get a denominator, and then divide the top by the bottom. Now, our bottom is really boring here, but they won't always be ones. I'll give you another example in a moment. But here we go. 15 times 52 times 7 times 24 times 60. On your calculator, spits out 7,862,400. All right, that's the top value. The bottom value is 1 times 1 times 1 times 1, which is, don't forget to carry the 1, is 1. So it would be that number divided by 1. Any number by 1's itself. So a boring example, but look, we have the answer. This is the answer to my question. If you were born 15 years ago right now. This dimensional analysis can be applied to any conversion. Let me show you one that's a little more applicable to us. Yes? We could have. It's just we would have gone from years to months and then maybe months to weeks. But it would have all given us the same number. Like it would have gotten rid of 52 and it would have given us a little bit of smaller numbers there. And we would have ultimately still ended up here. In lab today, you're going to be practicing this because I need you to get good at it. Using note cards. What you have in the back of the room is a bunch of note cards in 8 conversions I need you to do. What you and your whole table are going to do is you're going to look at the note cards. You're going to look at okay, it wants us to convert this, and you're going to move the note cards around to make them look the way my grid did, and you'd be like, yep, that looks good. For example, all right, and I'm doing one of your problems for you right now. One of the cards just says 5 kilograms on it because one of the questions says if you have 5 kilograms, how many ounces is that? You don't know the answer to that. You can't sit there and be like, oh, well, I was born 15 years ago. No, that doesn't work here, right? You're going to have to use my dimensional analysis to figure this out. You want to go kilograms to ounces. So what I would do is I would find the card that has the 5 kilograms, all right? You'll always have a card that perfectly matches the number that it starts you with. So here it is. And now I'm going to look for a card that will help me start converting. Hey, let me ask you this. If my grid is starting like this, whoops, kilograms. If my grid is starting like that, what units must be down here? Kilograms, right? Because we know that the units always drag down the diagonal, right? So what I'm going to look for is I'm going to flip through all my cards. I'm going to go, ooh, I need to find one that's got kilograms on the bottom, one that's got kilograms on the bottom. And then voila, you might eventually come by this card. You see how this card has kilograms on the bottom? Yeah. Now here, I want to warn you, just this doesn't have to do with this problem. If you flip the cards over that have fractions on them, it gives you the reciprocal of the same fraction. There's going to be one of y'all's groups that call me over. You're like, sir, I found the right card, but they're on the wrong sides. All right. Okay. Anyway, so check it out. I'm going to look at this card, and it says, all right, 1 kilogram is 1,000 grams. 1 kilogram is 1,000 grams. It's exactly what the card says. Hey, is grams what I'm trying to go to here? No, it's not. So we're not done. We need to find us another card. What must be true about this square down here? got to have grams in it because of the diagonal track. So now I'm going to go back, and I'm going to go look at my cards, Man, I hope there's one that's got grams on the bottom. Hope there's one that's got grams on the bottom, and then eventually, boom, you're going to find one with grams on the bottom. Do you see it? Do you see it? All right. And so what I'll do is I'll just keep my fingers crossed that maybe this is the last one. I look at what it says. It says that 28 grams is the same as 1 ounce. Is ounces what I'm trying to go to? We're done. Hey, this one's more fun because there's not just ones on the bottom. To solve it, I would go 5 times 1,000 times 1 is 5,000 up top. I would go 1 times 28 is 28 on the bottom. 5,000 divided by 28, and you've converted it. Now, a couple things before I release you back there. The cards can be reused. All right, so when you're done with the first conversion, mix all the cards back together before you start the second conversion. Don't try to use all the cards only once. It'll frustrate you. This isn't due today. You don't have enough time to, because it's going to have you do the 8 move the cards around thing, and then there's other questions. You're not going to finish it today, but when is everything due? Test day at midnight, which is forever away. All right, you got a ton of time. There's no stress. All right, you are working as a table. Labs will always be as a table, so it's all 4 of you in most cases. But here's the new thing. Listen, labs are always done in your composition book. All labs are in your composition book. Grab a Chromebook and go to your assigned station.